Yesterday, we began our study of trigonometry by learning about tangent. Today, we are going to talk about two more ratios that are called sine and cosine. So yesterday, we had the same picture saying that we are only, for this point in trig, and for most of trig, only going to be working with right triangles. Then we said within that right triangle, we want to select one of the angles on which we will place our focus, and it cannot be the right angle. So one of the other two. We never want to focus on the 90. So we're going to choose one of those other two. And this one we have that symbol theta in the corner telling us that that's the one that we are putting our focus on. Then from there, we label our sides as opposite across from the triangle, adjacent right next to the angle, and hypotenuse across from the right angle. Yesterday, we said that then we can set up a ratio and call it tangent of the angle is equal to, and tangent we said was opposite over adjacent. Today we're going to learn two more. The first one is called sine. We abbreviate it S-I-N, but please don't call it sin, it's called sine. Okay? Even when we abbreviate it, we still say sine. Sine, it says, is equal to the ratio of the length of the side opposite to the length of the hypotenuse. So that means that sine of our angle is going to be opposite over hypotenuse. We use the same format to set up all trig equations. We choose the trig name, whether it's tangent or sine or cosine that we haven't gotten to yet. Okay, we choose the trig name, and then an angle equals a fraction of sides. Okay, the sides are always over in the fraction, not with the trig name. Then cosine, which we're going to abbreviate COS, but still say cosine even when it's abbreviated, is equal to the ratio of the length of the side adjacent to the length of the hypotenuse. So cosine of the angle is adjacent over hypotenuse. They all have the same format. Trig name, angle equals a fraction of sides. Now you have to remember what those three fractions of sides are for each of the individual trig functions. To help students remember, many math teachers will use an acronym, SOHCAHTOA. I will refer to this acronym. What it does is it takes each trig function and then tells you which pieces you use for that trig function. So the S stands for sine, OH, opposite over hypotenuse. C, cosine, AH, adjacent over hypotenuse. T, tangent, OA, opposite over adjacent. This is really helpful in remembering what those three fractions are if you can spell it. If you can't spell it, it will not help you because everything is all in the spelling of this word. So if spelling is not your thing, and you're like, great, the memory trick isn't going to help me remember because I can't spell it, then something else that many math teachers suggest is to make a story out of the letters. So one commonly used story ignores the S, C, and T, so you have to remember that they're going to come in that order, but then just take the other letters and make a word story out of it, saying something like Oscar had a heap of apples is a commonly used story that different math teachers have used. Or you can make up your own story using those letters. But in whatever is going to work for you, you need to learn what these three different ratios are. Which sides go with which of the trig functions. In today's lesson, most of the problems are going to ask you to solve for one or two sides of a triangle and for an angle of a triangle, or for an angle of a triangle. It will not tell you which trig function to use, so you need to determine that based on what we know and want to know. Today's lesson also does not just use sine and cosine, but tangent is fair game as well. We're accumulating this knowledge. All three trig functions can and will appear to be necessary in problems today. Okay? So SOHCAHTOA, I will refer to, but if that's not going to work for you because you can't spell it, then make up a story for yourself or use Oscar had a heap of apples or whatever you need to be able to remember what those three ratios are. So for our first example, we've got our right triangle We're given one angle of it is 67. We're not given the other angle, but we could find it if we wanted to because it's a triangle. We already know two angles. We could add it up and find out what's left from the 180. We're asked for two sides of it. We can only find one thing at a time, so let's find x first. I'm going to focus on the angle that I'm given. According to that angle, which side of this triangle is x?
Opposite.
Opposite. So if I'm trying to solve for x, I want to make sure I'm using x, which is an opposite. I need to use the 120 as well, because using x and y won't help me because then I have too many things I don't know. You can only work with one thing you don't know. So what kind of a side is 120?
Hypotenuse.
Hypotenuse. So if I want to solve for x, that means I need to use an opposite and a hypotenuse. Which trig function is opposite and hypotenuse?
Sine.
Sine. Format is the same for all of them. Trig name, so sine in this case, angle, 67, equals, and then the fraction for that trig name. Sine is opposite over hypotenuse. Yeah.
Button the same or?
We will use a different button. But it's like one over from it. They're all right in a row together. The process is the same. We're going to multiply both sides by 120 to get the x alone. And then we're going to evaluate this on our calculator. Again, remembering if you're using a real calculator, a standard calculator, you can type it in just like it looks. 120, sine is like two buttons over from tangent, but they're all right there in a row. And then 67 and hit enter. If you're using an I product calculator, you have to type it in backwards. 67 sine, enter, times 120. Okay. Either way, we should get to the same result and find that it is about 110.5.
Nice.
I have a question.
Yes.
For angles, do we have to do second sine and second?
Yes, for angles, we'll still do second, whatever trig function we're doing.
Do we know how to round these? Is it like by one decimal?
Typically, the directions in the book say sides to one decimal place and angles to a whole number. It's kind of their general way they write directions.
I have a question. So for y, will you be able to either use the opposite or hypotenuse since we know what the opposite is now?
Yes. So in solving for y, we would have some options. It is my belief that it is best to always, when possible, not build from previous answers. Just because if we got this one wrong and we do something using this, everything's going to be wrong after that. So I like to, if possible, always go back to just given information. Because then I can still get part B right even if I get part A wrong. So when I go to solve for y, I'm going to focus on the same angle. But if I'm solving for y, then I care about what kind of side y is. So what kind of side is y?
Jason.
Adjacent.
Adjacent. Cosine.
And I want to use, again, just the given information if possible, which is going to be hypotenuse. We could, since we know what x is, use that, but I like to not if I don't have to. So if I have adjacent and hypotenuse, maybe I already said that's going to be our cosine. So cosine of angle is adjacent y over hypotenuse 120. Multiply both sides by the 120 and type that in using our cosine button, which is right between the sine and the tangent buttons. And we find that y is about 46.9. Yes.
Are there formulas for sine, cosine, and tangent?
What do you mean as in formulas?
As
These
in-
are the formulas, like
Well,
opposite
yeah,
over
but,
adjacent.
how does the calculator know the difference? Because those two problems are identical except for sine and cosine. So how would you know what the difference
Are you
is?
asking how you do it without a calculator?
Yeah.
Okay.
basically.
So those are two different questions, really, kind of. If we're trying to do it without a calculator, so how they did this before they had calculators is in the textbook, and there's actually one in your textbook. There's a table of trigonometric values on which you would look up the angle 67 and those are all in rows, and then you would find the column for cosine, and it's going to give you a long decimal value, and then you would multiply that decimal value by 120 by hand, since we're not working with a calculator, and it's not a great thing to do. But that is how it was done before calculators. I don't know, to be honest, what kind of algorithm the calculator uses to solve them.
And will we, in any form of math, like even like college math, will we ever be expected to find those trigonometric values for the angles?
For a few specific angles, yes, and that's not college math, that's like in a week and a half. For some specific angles, that's where our 30, 60, 90, and 45, 45, 90 triangles become extremely important to us. That then we will be able to find some of these without our calculator, but for 67, you would never do that without a calculator.
On the calculator, the second, if you press second, it's going to do the same thing as the tan, right?
Right. Yep. And that's what our next question is, actually solving for an angle.
Okay.
So in our next example, we're looking at solving for an angle. When you're solving for sides, you can choose which of the two acute angles that you want to focus on. When you're solving for an angle, you need to focus on that angle. So according to that angle, what kind of a side is 22? And what kind of a side is 40? So opposite and hypotenuse is which trig function? Sine. So sine of n, it's always trig function, angle, equals, and then our fraction, which for sine is opposite over hypotenuse. Now on your calculator, when solving for angles, no matter which trig function you are doing, you will need to do the second. So if you're using a real actual calculator, you're going to type in second sine 22 divided by 40 and hit enter. If you are doing an I product, you're going to type in 22 divided by 40, enter, second sine, enter. And we get n is about 33 degrees. Usually your book will say for a side to one decimal place and for an angle to a whole number. Okay? I have one more example I would like us to look at. All right, we can choose which angle we want to focus on. So I could use the 35, or I could find out what that top angle is, and it would be 55, and I could focus up there if I wanted to. Not the 90, can't ever focus on the 90, but I could choose which of those angles I wanted to focus on. I'm just going to go ahead and use the 35 that I'm given. Then if I'm solving for x, x is what kind of a side? Hypotenuse. If I am solving for x, I cannot use side y because that would be too many unknowns. So I have to use the 14, which is what kind of a side? An opposite. So which trig function uses opposite and hypotenuse?
Sine.
Sine. So I'm going to set up then sine of 35, always trig function angle, equals, and then for sine, the fraction is opposite, 14 over hypotenuse x. Yesterday I told you that when working with tangent, it would always make your problem easier if you would select the angle that is opposite of the thing you were looking for, because that would put your variable on the top, and that's easier to solve algebraically. If we're solving for our hypotenuse, there's no way to get around the variable being at the bottom, because in those ratios, hypotenuse is only on the bottom. Right? It's opposite over adjacent, so there's not even a hypotenuse there for tangent. And then opposite over hypotenuse or adjacent over hypotenuse. It's only on the bottom. So there's no way to kind of fix the problem that happens here. So we just have to deal with it algebraically. It's not terrible. It just takes one extra step to solve, but I want to go through an example so that we can practice this algebra. So what we're going to do is multiply both sides by x to get rid of the fraction. Okay, our goal is to get x alone so that then we can type all the numbers into the calculator. So I'm going to multiply both sides by x. That'll cancel the fraction, but x still isn't alone. X is now with the sign of 35, so we're going to divide by the sign of 35. That will cancel over there, so now x is alone.
So wait, why couldn't you just do? Yeah, why couldn't you just do 14 instead of x?
Because that's on the top of the fraction. So if we multiplied by a 14, we would do 14 times 14 is the way that fractions work, and that's not helping us get rid of the x. We have to multiply by the bottom of the fraction because that's what will cancel a fraction.
Sign
Yes, 35. Thank you. Thank you. Glad to know so many people are paying attention. All right. So we get 14 over sine 35. If you are using a real physical calculator, you can type that in, just as it is. 14 divided sine 35, enter. If you're using an iProduct, this is a little bit more annoying. You're going to have to type in two things. You are first going to type in 35 sine and hit enter. It's going to give you a long decimal that you're going to need to write down at least a few digits of. So, get my calculator in the right mode here. So I get 0.574. Okay? So I'll need to write that down. That's not my answer, but you'll need to write it down because then you're going to need to do 14 divided by that decimal. Keep a few decimal places. Don't round it too much because that will change your answer significantly. And type that in, and then that will give you your final answer, which is about 24.4.
I did divide by 14, I still got the same answer.
You did what divided by 14?
I kept x on the right side and I just divided by 14 on both sides.
You can't keep x on the right side because it is going to be on the bottom of a fraction. If you keep x on the right side and divide by 14, you can divide by 14, but you're going to have sine of 35 over 14 equals 1 over x. And we want what x equals.
Oh, I got that.
I still got the answer.
You got lucky. This is probably some sort of a special case that's going to help you be lucky there, but don't do it as a general rule.
Could you multiply the right side by 114, and then you'd have 14 over 14x, and then you would have just that?
No, if you multiply by that, you would have 1 over x. Because the x is still on the bottom. You haven't done anything to fix that. And we don't want an x on the bottom, we want an x on the top. Okay. Let's go ahead and look at how we would solve for y. I'm going to go ahead and use the same given angle. What kind of a side is y? Adjacent. And if I don't want to base my answer off of x because it could be wrong, then I want to use the 14 again, which is still going to be opposite. Listen up, please. So if I'm using opposite and adjacent, which trig function do I need? Tangent. So we're going to do tangent of 35 equals opposite 14 over adjacent y. Yesterday we talked about how with tangent we can actually fix this problem of having our variable on the bottom by selecting the other angle. So if we would use that top angle of 55, we could fix this. I'm not going to do that here, just so that we have another example of practicing how to solve this. So to solve this, we're going to multiply both sides by y and divide both sides by tangent 35. So that gives us y is equal to 14 divided by tangent 35. Or again, on a graphing calculator or scientific calculator, you can just type that in. 14 divided tangent 35. On an iProduct, you have to do it in the 2 steps and type in 35 tangent, enter, get your decimal, and then do 14 divided by that decimal.
For an angle, we would still have to do.
For an angle, we would still do a second. So that ends up being 19.99, or we'll just call that 20.
Will it ever give you like, where you have to solve for a side and for an angle using these in one problem?
It could, I don't know if it does. So in your homework, all three trig functions can be used. So it's not just that this is this lesson and today we learned sine and cosine, so we're only going to use sine and cosine. You might still use tangent. There's some accumulation of knowledge that's going to happen here. You need to determine which one of the three you will use based on what you know and want to know and select the appropriate ratio. Okay? So the assignment for tonight comes from 8.6.